So I have my kites here on page 9. We're going to talk about a couple of these things. It has congruent consecutive sides. So, you know, as you recognize kites, hopefully you've seen one before, kind of know what they look like, and this isn't the first time ever. But like, typically when you look at a kite, it looks like this, and like the top two are the same, and the bottom two are the same, but it has two sides that are not opposite from each other. They're like consecutive sides that are congruent. It has two sets of those. Okay? The opposite sides are not congruent. The diagonals are always perpendicular, so just like a rhombus, the diagonals are perpendicular. They have exactly one pair of congruent opposite angles. So what that means is like A and C, this whole angle here, A and the whole angle C is congruent to each other. They have exactly one pair of congruent opposite angles. And then the shorter diagonal is bisected. That is like the case almost always. It is possible for that to be different, and I will show you the example where that is different on number 9, where the longer diagonal is actually bisected. But for typically, if it looks like a normal kite, this one gets cut in half. So we are going to put little markings there to show that they're the same. I'm actually going to put 3 of them on each one, because it's not the same length as these, but they're the same as each other. All right, then lastly, the longer diagonal is an angle bisector, okay? So it's the one that it typically looks like the longer diagonal. Is that always going to be the case? No, it's not always going to be the case. But it's, if you're looking just like at a typical kite, it's the one that cuts, these angles are cut in half by this diagonal, and then 2, 3. These angles are cut in half as well. All right? Okay, this can be overwhelming. If this stresses you out, don't freak out, because all this is has all of these markings listed. So if this is something that you're like, I don't want to look at that because there's a lot going on there. As long as you can interpret what this is saying and what these markings mean, that is what this says down there. So don't overthink that. All right, there's a lot going on here. There's a lot of questions. There's going to be a lot of numbers on here. And the reason why I do this, like, there is a method to the madness. There's a reason for this. The main reason is that all of these angles in here, they kind of work together, because 4 right triangles are created by these diagonals. All of the angles of a right triangle add up to 180. So it is going to look like a lot on here, but a kite is really just like a big puzzle, and once you find one piece, you can kind of work your way around and find the rest of them. So we kind of need to show you all on the same picture. All right, let's mark what is written, or what's given to us. So like ED is 12, EC is 5, ADE is 23, ABC is 86. So like this whole angle is 86, but it gets cut in half. It gets bisected. So we're going to take 86 and we are going to divide that by 2 to get 43, and that's what goes here and here. Because this gets cut in half, so I think it's easier to just write those 2 things on there. And I think that's all. Yeah, so the fact that AC is 10, we know both of these are 5. It's also, we know that it gets bisected. This piece right here gets cut in half. So, all right, I think we are ready to attack this problem. All right, first thing, we're going to deal with some sides. You're going to do some Pythagorean theorem today. You're going to have to simplify radicals, not till we get to the next page, because this one comes out to a whole number, but just know that that is in your future. You will have to simplify radicals again this unit. All right, so I plugged these in. Why am I doing this? Because this is a right triangle. How do I know that? Because one of our properties was that the diagonals are perpendicular. So we have a right triangle created. So if we add 5 squared and 12 squared, we're going to get 169. And then we take the square root of that, and it comes out to a nice, pretty whole number of 13. So this side length, CD, is 13. And then we also know this one is 13 as well, because they are the same. All right. So I wrote in the properties that the diagonal that is longer bisects the angle. It's not always the case, but typically it's the one that's longer. It's the one that cuts this in half where it's identical on both sides. Like this cuts it in half to where this is identical to this piece over here. If you use this one, like notice it's not like identical. Like this triangle over here, this big one, is not the same as this triangle over here. So that's how you know which angles get bisected. We're going to get to that in just a second. Before we get to that, AED asks for, it's this one. Well, all these 4 angles right here are going to be 90. And now we can get back to what I was just talking about. CDE, so this angle right here, it's bisected by this diagonal. Like this big angle D is cut in half by this diagonal, so we know that that one's 23. I know that because this diagonal cuts these 2 angles in half. All right, because this triangle on top is identical to this triangle on the bottom. All right, and then we have CDA, so the whole thing is going to be 46 because you just multiply by 2. And then BCD, so this angle up top is what we're looking for, this whole angle. So what you can do, I think the easiest way to do this is to look at this and just like only look at this top triangle. All right, so you see this triangle ACD? No, that's a B. Never mind. BCD, this one right here. Those 3 angles will add to 180. 43 plus this big angle right here, act like it's not cut by that line, plus 23 is going to equal 180. So we can solve for that. 43 plus 23 plus angle BCD equals 180. So to get this angle, you just subtract those 2, which this becomes 66. And if you subtract 66 on both sides, you get 114. And that's what this angle is up here. This is 114. How did we get that? Because we realized that this is a triangle. There's a lot of triangles within kites that add up to 180 degrees. All right, and then EAD. So make sure you realize that this side and this side, these 2 angles are not the same as each other. So we are just looking at this triangle right here, EDA, and we can realize that this one's 90 degrees. This one's 23 degrees, and then this is the angle we're looking for. Angle EAD. They're all going to equal 180. So if we subtract, we can get 67 degrees. So I did 180 minus 113. You get 67, and that goes right here. And then a shortcut to doing that, this is a right triangle. You could just subtract 90 minus 23 to get 67 as well. But you can do it this way as well. This just takes longer. So we've labeled what's given, and then we know that these 2 sides are congruent because this cuts the kite in half. So EA is going to be 6, we can write that, and then AD is going to be 12. We know these 2 are the same, so that's how kites work. And we're going to do Pythagorean theorem 2 times. The first one I'm going to do is this one over here. 5 squared plus 6 squared equals c squared. How do I know I can do that? Because this is a right triangle here. This is a right angle. They're perpendicular. If you add these together, you get 61. The square root of 61, and 61 is actually a prime number, so it cannot be simplified. So we're just going to write that in for these 2. So this is 61, and then how was I able to write it in for this one as well? Well, because these are the same length. All right. All right, we're going to do Pythagorean theorem one more time. This one we will practice simplifying the radical, and we'll do that in the calculator together. But just remember, when you're plugging this in, you are looking for this side right here. So it's 6 squared plus b squared equals 12 squared. I cannot tell you how many times I see people wanting to do 6 squared plus 12 squared equals c squared because they're kind of used to doing it like that. But this is asking for a side that is not c. 12 is c. So just plug them into the right spot to keep you from getting mixed up there. And then grab your calculator. I would suggest typing this into your calculator as I do this, just so you remember how to do it, because it's been a little bit since we've done this. But if you remember, you go to y equals, and then you type 108 divided by, and then next to that green button is the variable. So you just click on that to get that x value. All right, so 108 divided by x. Then you want to get the table. So you've got to click second graph, and it's going to give you this table. If you don't know your perfect squares, you probably need to learn them. It just is going to make your life easier, because you want the largest perfect squares, or square, that multiplies evenly into your number, 108. And 36 is the largest one. The thing is, 4 also multiplies evenly into 108, and so does 9. And those are perfect squares as well. But remember, perfect squares are like 2 times 2 is 4. So 4 is a perfect square. 9 is a perfect square because that's what 3 times 3 is. 16 is a perfect square because that's 4 times 4. And so since we're taking the square root, we split them apart, and one of them is a perfect square and one of them is just a random number. Whatever number gets multiplied into that perfect square to equal 108. And notice I'm putting my perfect square first, even though it's written second here. And then that simplifies to 6 root 3. Can that go to 3 root 6? No, it cannot. The 6 comes out of the square root. The 3 has to stay in because it can't be simplified. All right. And then this last one does not take very long. I'm going to solve for this angle first. And the way I'm going to do that is 90 minus 35. Why am I doing that? Because these 3 add up to 180. But if you subtract 90 from both sides of the equation first, you can realize that you can solve for this angle because all 3 of them will add to 180. All right, and then I'm just going to set up this equation for you because this is the exact same problem as number 5 on your assignment. So I'm going to set this up, and then I'll let you guys solve it on your own. But what I'm doing, which there's different ways to solve it. If you see a different way and you can get the correct answer, then great. But in order to solve it, I'm setting angle D equal to angle B. So I'm adding these together, putting an equal sign in between it.